In the context of global climate change, most Mediterranean cities have undergone significant warming during last decades, which is more pronounced in the summer. Meanwhile, the increase in the mean air temperature is accompanied by the increase in the frequency of hot extremes. This was the motivation behind the development of a fully automated system for the continuous monitoring of land surface and air temperatures of European cities in real time every 5 minutes at 1 kilometer resolution from space. Realizing the importance of monitoring the thermal urban environment and the existing gap in data and system availability, the Institute for Astronomy, Astrophysics, Space Applications and Remote Sensing of the National Observatory of Athens has developed a system for continuous monitoring of the urban environment at high spatial and temporal resolution. Now we are going to demonstrate the portal. We will start by nowcasting dashboard. When you start, you see the map of Europe, and on your right you see a list of cities. At the moment there are 16 cities, but this list is going to be increased in the future. Underneath you will see a list of parameters. Let's start by choosing Athens land surface temperature. Land surface temperature is a parameter that is directly measured by the satellite sensor. If we choose to plot the terrain as well, since Athens has an interesting terrain, now you see the real-time distribution of land surface temperature over Athens. You will see that the mountainous areas around Athens have lower land surface temperature, whereas the city of Athens in the center has actually higher land surface temperature. Let's now try another city like Barcelona or Brussels, London. Again here you will see the distribution of land surface temperature for London, and you will see the urban heat island effect, where the center of the city is actually warmer than its surroundings. It is interesting to note the different parks, for example Regent's Park here in London. Another interesting example is Cairo. Cairo is quite interesting because it is in the desert and it actually lies near Nile. So you see the delta of Nile that is clearly cooler than the desert, and here is the city center. At the moment, the city center is actually cooler than the desert, but later in the day it becomes warmer and it actually develops an urban heat island. We can choose another very warm area, for example Dubai and Abu Dhabi, and this is the distribution of land surface temperature now, as it is seen by the satellite. Again here you will see that the desert is really very warm and the cities are cooler. This relationship is actually changing during the course of the day, and at night time the city centers become warmer than the desert. We can now choose to move to a different parameter. For example, we can see the air temperature. This is a combination of information from a model and information from the satellite. Actually, it is an assimilation of the land surface temperatures from the satellite into a GFS, which is the Global Forecasting System. You see that the air temperatures in Athens are actually higher than the surroundings. This is a not very well developed, but it's still there, the phenomenon of urban heat island. We have also covered some islands, for example Majorca and Cyprus. Majorca is actually one of the cities covered in TREASURE. TREASURE demonstration cities are Athens and Majorca, Palma de Mallorca. You see the mountainous area, this is Tramuntana, and the air temperature is actually lower, as it is expected, than the city of Palma. We can also see Rome, for example, Madrid, Barcelona, which has some interesting topography, Berlin, Hamburg, and again Dubai and Abu Dhabi. From the GFS model, we can also get an estimate of relative humidity. It is the combination of air temperature and relative humidity that can give us an added value product that is humidex. Humidex is an indicator that is related to the discomfort of the population to the heat. For example, now let's go to a really warm area like the United Arab Emirates, and you will see that the maximum humidex is 4. This is what corresponds to red here. The same is for Cairo. This is a combination of air temperature and relative humidity. The timestamp shows you that this information is actually real time and it is refreshed every 5 minutes. Another parameter that is related to the discomfort of the population is the apparent temperature. Again, this is an indicator that comes from air temperature and relative humidity. And we also have 2 more parameters here. One is the heat wave hazard, and the other one is cooling degree hours. Heat wave hazard has to do with the difference above a threshold. When a temperature is actually above a set threshold that is different for different cities, then this gives the distribution, the spatial distribution over the whole area, and it gives you an indication where the heat wave hazard is actually higher. Of course, this is only applicable in warm areas during warm days. Cooling degree hours, on the other hand, have to do with the energy demand for cooling. Apart from the nowcasting, which is the real-time measurement as it is happening now, we have the possibility to look back in time. This we do it via charts. In charts, you have 3 options: to plot a single parameter, multiple parameters, or a single parameter but for multiple cities. So let's first start with a single parameter. Again, you choose one city and the parameter you would like to plot. So now we have chosen Athens air temperature. This is the last 2 days of the time series for Athens, and you have the possibility to show all. So it goes back from the beginning of our database when we started recording the temperatures for the city. Let me now stress that for each city, what we do is that we keep the average for the whole urban area only. So the temperatures that you see here are the urban temperatures. You can play around with the slider. Keep in mind that every peak corresponds to 1 day. So this is the diurnal evolution of air temperature for the city of Athens for these particular days that you see. We hope that with time, the value of this time series is going to increase because we will be able to see trends and we will be able to compare between years, which is something quite important. So we can choose any other city. For example, if you choose Cyprus, what you will see is the urban areas. So this is the average together with the maximum and minimum that you see as a yellow buffer, only for the urban areas for the whole island of Cyprus. Let's now move to multiple parameters. Let's choose Mallorca, and you have 3 preset options. The first one is to use land surface temperature, air temperature, relative humidity, and humidex, which is the index that has to do with the population discomfort to heat. We will fetch the data from the database, and here you see the different parameters for the last 2 days, and the blue columns correspond to humidex. At the moment, humidex is 1 for Mallorca. If we go back to the previous summer, you see more high values of humidex. You see higher values of humidex together with land surface temperature, air temperature, and relative humidity. From the legend here, you may choose not to show some of the parameters. So let's just see the air temperature and humidex, for example. With the same way, you can see the heat wave hazard and the cooling degree hours. Of course, the same can be seen for all the cities that are covered by our system. Another option is to compare the behavior of the diurnal time series for different cities. For example, let's choose Athens and Mallorca, which are the cities, the demonstration cities of TREASURE project, together with Cairo, for example. And let's choose to see the air temperature. Again, you see for the last 2 days, but of course, you can go back in time and you can select the time window of your interest, where you will see the different time series for air temperature for the 3 cities. Red is Athens. At this particular time window, a bit warmer is Mallorca, and of course, the warmest of the 3 is Cairo. Here you can also see the magnitude of the diurnal change for air temperature that is different between different cities. And of course, how this change, these distributions, these relationships for the 3 cities change also with time and with season. Now it's time to actually look at an application that we have developed for citizens. This is a personalized heat wave risk estimator that is also available as a mobile application. So we start by launching the application, and your mobile will be able to find your position. Now we are at the premises of the National Observatory of Athens, in the center of Athens, and this is our position shown by the marker. So if we press risk, we see that at the moment outside the temperature is 29.7. This information comes directly from the assimilation of the satellite measurement into GFS. So this is the TREASURE estimation of air temperature, and it is from the satellite, it is not from a meteorological station. According to the model, the relative humidity outside where we are is 33%. So for a person for whom we have not input any specific characteristics like their age or maybe any intake of medicine, the personalized risk is quite low. However, we have some possibilities here. One of the possibilities is to actually create some profiles. The profile can be the profile of the user, or can be the profile of a person that the user is responsible of, like their parents or their grandparents. So let's play around with profiles, and let's put, for example, George, who is male and who is 45, has no chronic disease and takes no daily medication. Let's submit this profile, and let's add maybe his mother. So let's put Maria, who is a female, and who is 85. Let's say that she has a chronic disease and she does take daily medication. We submit the profile. So now we can go back to our home screen, and let's say that George is at the National Observatory of Athens, and he chooses to see what is the risk for himself. As we said, because George is quite young, it is low risk. Let's see what the risk would be for his mother. Go back to map, we choose Maria, and we see that for the same conditions, the personalized risk for Maria is actually higher than the one of George. This is due to the fact that Maria is much older and she has a chronic disease for which she takes daily medicine. Another opportunity that we have here is that, for example, maybe his mother is not together with him at the moment, so she is near her home. So let's say that she lives in Kypseli. So we can either type the address, or you can move the marker and find the right address on the map, or you can put the exact address at the address box here. Again, if you see the risk, the conditions are quite the same because Kypseli and the sea are not that far away from each other. So you will see the risk based on the location of Maria at the moment. Another interesting thing is that you can show the cool places that are around Maria, the nearest cool places around her. So here you have three options. These are the ones that are close to her, and you can either walk or you can go by car, depending on how far these places are. There are again routing instructions to show you how Maria can actually go from where she is at the moment to the nearest cool place. This mobile application does not work only for Athens, it works for other cities that are covered by our system. For example, let's say that now Maria is in Mallorca, Palma de Mallorca. Let's see what is the risk now. Well, the air temperature at this moment, at this location, is almost 20 degrees with high relative humidity, higher than Athens, 52%, and the personalized risk for Maria is not very high, it's actually lower than Athens, as the air temperature is almost 10 degrees lower than Athens at the moment. Nevertheless, we can see the cool places. Again, actually, Maria is very close to one of the cool places, just across the street, just a coincidence, and other cool places that are given to us for Palma de Mallorca. So the idea of this application is that you can monitor the personalized heat wave risk both for yourself and for persons that are under your responsibility or you are interested in, and they can be either at your city or they can be in the other cities that are covered by Treasure. One of the applications has to do with applications for the authorities, in particular, the distribution of ambulances across the city. Let me be a little bit more clear. Based on the nowcasting heat wave risk that we take from the satellite, the objective here is to find the optimum location of the ambulances across the city so that the response time to the increased demand due to the heat wave is actually minimized. So let's, for example, take Rome as an example. Let's say that it has 15 zones to cover and a fleet of 50 ambulances. So if we now take into consideration also the heat wave risk that we have now, which is really very low for our example here, so it is very close to the baseline, we see the distribution of the ambulances across the city. So the solution here is 15 zones where you have distributed 50 ambulances so that the maximum zone coverage is 7.4 minutes. This means that if you put 4 ambulances here, 5 ambulances here, it means that the maximum time that you will have to cover the increased demand within the corresponding zone is actually a little bit more than 7 minutes. You can play around with more zones, or you can actually increase the fleet. And with this, we have improved a little bit the solution. And this is how this application works. This can be very useful when you actually want to plan in advance, or to plan what are your resources, where you should place your resources in case of a heat wave event.